Hey there, welcome everyone. We're here today to look at an example of using Ohm's law. Now, by the end of this video, my hope for you is that you can apply Ohm's law, which is an equation, to basic electricity problems and you're able to solve those. So let's go down and get started. So let's suppose we have a circuit is seen here. We have a battery here and we have a resistor. There are measured values of current. Current here is I, and the current going through this resistor is 400 milliamps. We have a voltage going across this resistor of 6 volts, and the resistance is the thing that we're trying to find. This is the goal of our problem, is to find out how much resistance this thing has. So one of the first things I like to do when I start any problem is I want to look at the units that I'm starting with. I see milliamps here, I have volts here. Now, this is what I would refer to as a red flag situation. Why exactly a red flag? Well, if you notice right here, we have milliamps. Basically, I want to make sure that all of my units are in basic units. I don't want to have the milli hanging around. If there was a kilo or a mega or any kind of those other prefixes, I don't want them hanging around. So to change this, I need to do a conversion. Now, I'm not going to take time right now to show you the conversion, but when I do convert into amps, I'm going to end up with 0.4 amps. Now, let's move on. If we take a look at the equation that drives Ohm's law, or what is Ohm's law itself, Ohm's law is the voltage in a circuit equals the current times the resistance. My goal here is to actually get the R by itself. Notice over here I have I, current, times resistance. In order to undo multiplying by an I want to actually divide by the I. Now what is this going to do? This is going to allow me to cancel out the I on this side. Okay, so my I is actually getting canceled out because I'm dividing by it. Now you've got to remember, algebraically, when I divide something on one side, I have to do the same thing on the other side. So I notice here that whenever I divide by I over here, I'm going to do the likewise on this side as well. And doing so lets me with the equation that the resistance equals voltage divided by current. So I'm ready to actually take this equation that I have here, and I'm ready to substitute some numbers in. So let me get rid of the V, and in its place we're going to put in the value that we know from our problem, and likewise we're going to take this current out and we're going to replace it with the current that we have. And again, this is already converted. When I do my math in the calculator, let me just bring my calculator up here real quick. Right here's my calculator. I'm going to take 6 and I'm going to divide that by 0.4. And I end up with 15. So let me get rid of this, bring in my answer here. The answer that we get in this particular problem is that the resistance of our resistor is 15 ohms. Now let's take this a step different here. Let's suppose that in this case I'm told that I have 6 volts, the same 6 volt battery, and this time the resistor is 2 kiloohms, and I want to find the current going through this circuit. So one thing here is we've got another red flag situation. We have this kiloohms. Again, when these prefixes are in here, I always suggest going back to the base unit. So when we go back to the base unit, what we're going to end up with here, let me just grab it off the screen here. and bring it back in. Again, I'm not going to show you the conversion itself, but if you're having problems with the conversions, go back and look at some of my previous videos with how to do conversions. Now, when we go ahead and do this, we're going to take our equation V equals IR. Notice again, I want to get the I by itself, so I'm going to divide by R. When I divide by R on this side, or the reason I divide by R on this side, is because it actually cancels out here and here, and then I'm left with just the I, which is my goal. Over on my left-hand side, I end up with V divided by R. So my equation ends up being V divided by R equals the current. Next up, I'm going to substitute and solve. So I've got my equation here. If I take my V out and I put in the V that I know, 6 volts, it goes in here. Taking out my R and putting in the value that we actually know, that's 2,000. When I take 6 volts divided by 2,000, let me bring my calculator back up again. Calculator right here, we're taking 6 divided by 2,000. We end up with 0.003. So let me write that down. 0.003. And what we're dealing with here is a volt per ohm. This is also a unit of current, but we typically don't call it a volt per ohm. We actually call it the amp. So again, in this problem, it doesn't specifically say we need to convert this to milliamps or anything like that. So we're going to leave it in just the amps. And again, we know this is in a base unit here because of the base units that I start with. So, in conclusion, we have an equation. As long as the circuit that we're dealing with behaves in an ohmic way, we can use the equation V equals IR. We can solve it for any of the variables that you find in it. And after substituting in our known values, we can actually calculate something using Ohm's law.